Hi everyone. So welcome to this session. It's our first time here for the Linaro event, so hope you guys can enjoy it. And so let's start. In this session, we will show you guys about our team and what we have done trying to make the life easier for big data users on ARM. And we will also include some other fields like cloud and general libraries. So we will share what we are currently doing and our future plans. So let's jump to the, this is how the content are organized. So let's jump to the first part. So who are we? We are from Huawei and our team is called Computing Open Source Ecosystem Department. Which means our job is to work on upstream open source communities. And the goal of our team is to enrich the open source software ecosystem around ARM-based data centers. The software will include OS, libraries, cloud and virtualizations, storage, web. And I think the most of you guys are more interested in for this topic is the big data area. It is actually, it's actually a full stack of data center software ecosystems. And since big data is one of the most commonly deployed services in data centers, we put big data with very high priority in our tasks. So how we gonna do to reach our goal? Here is what we have in mind. First of all, we have to identify the gaps to run on platform of projects that we are interested in, and then we fix them so that the software can be run on ARM data centers. And not just it's not just on our own fork. We will push them to the upstream so that everyone else can be benefited. Secondly, we will introduce and enable CIs to those projects so that in the future development of those projects, they will be tested on platform. And also people who are interested in fixing gaps on platform could also have a clear view about what the gaps are and the current process of the fixing. Then we will try to push the upstream to provide an ARM platform release so that the ARM users can easily download and use them. So also enhance the docs about how to run it and debug them on ARM platform. So the threshold of developing them on ARM platform will be lower. And as a part of the final step, we will proposing patches to upstream so that they will perform better on ARM platforms, and this will make the ARM data center more competitive. So these are some background information about our team and what we are, our way of doing things. So please let us spend 1 minute to give you some information about ourselves. Let me welcome my colleague.
Hello, everyone. I'm Liu Sheng. I'm focused on promoting open source projects in big data area, running on ARM platform. I have done some work about building Hadoop CI for Hadoop community and others. I'm currently working on ARM support for Kudu project.
Hello, everyone. I'm Bo Zhao from China, working in Huawei. Now I'm working on ARM in DB area. It includes MySQL, MariaDB, Percona, PostgreSQL, GreenPlum, and MongoDB. Thanks.
Okay, my name is Zhenyu Zheng. My current main focus is on the virtualization area, but I have also done some porting works with big data like Hadoop and Hive. Okay, let's beginning our talk. So, what are the challenges about our job? About our goal? Is it an easy job? Actually, it's not. There are a number of things that we have that we meet make this hard. There are some typical ones. Firstly, ARM has been a second-class citizen for quite a long time for data centers, and we have to admit that not all of the developers are interested in making their software to be able to run ARM. And the ability to be able to run on other platform does not make any sense to their daily work. So when we send out our ideas in the mail lists and Slack channels, not much people replied at the beginning. And the next one is the software projects normally has a lot of dependencies. And for open source projects, the number of the dependencies and is very large. And sometimes the relationship between them sometimes is very complicated. And sometimes, for example, some old dependencies are not actively maintained, or some dependency does not support ARM well, and their dependencies does not support firmware also. So this will be very hard. And nevertheless, people does not understand ARM platform enough. Some of them even don't know that there are ARM-based data centers. When we first send out our ideas in the public channels, many people ask us why we want to run big data software on Raspberry Pis. This could also be a part of the reason why people are not interested to make their software running on ARM. And all those together are very challenging. And there are also some others that I did not list it. So what we have done so far. According to our methodology, I have just introduced, in order to make our job done, either by our team or by someone else in the community that are interested, we have to provide the resources to them. And we have donated a lot of them through various ways according to the upstream preferences. We have donated 2 powerful machines to Apache Jenkins so that the project uses Apache Jenkins can use these resources to run their tests. And some of them already did. We will cover this in the next few pages. And some other projects like Spark does not use Apache Jenkins. They uses their own system. So we donated servers to their own system. And they have already set up CIs running. We have also open source CI platform that based on Zoo, which can provide dynamic resource and tests using job descriptions. Projects like Apache Flink and many other CNCF projects connect to this CI platform and run their CI jobs. You can find the details in the links. And also for this Open Lab platform, I want to thanks to Linaro Developer Cloud, as it has donated some machines to this platform so that we can make our ARM resource pool larger. There are also some projects that ask for raw machines so that they can have more control on them, and they can do other jobs like packaging and other stuff. Those projects include MariaDB, RocksDB, and X265, and many others. So after donating those resources, we have to make use of them. We have enabled numbers of CIs for famous projects in the big data area, such as Hadoop, Spark, HBase, Hive, and Flink. You can check for details from those links in case you are interested. Some of them are periodic jobs running per day, and some of them are pre-committed tests according to the preference of the projects. We have also done some works in other fields which might also be good to know, such as MariaDB and other web-based projects. Another thing I want to now let me pass my microphone to my colleague Liu Sheng. He will introduce some details about the what we have done in the big data area.
Okay, let's look at some detailed information about what we have done in big data projects so far. As mentioned, one of the challenges for porting software on ARM is the dependency problem. Now let's see some real examples. There are different kinds of problems and we have handled them differently. First, when we try to fix Hadoop, one big blocker is the protobuf, since Hadoop still uses 2.5.0, which is quite old, and it does not support the ARM platform. But the newer version of the protobuf does support ARM. So the normal way is to bump the Hadoop to use the new version that can support ARM. It could be challenging since bump from protobuf to protobuf 3 is a major bump, and many projects are afraid to do that. We have discussed with the community for quite a long time, and although there are back and forth, but we have finally done it so far. So for dependencies that can support ARM in newer version, we try to bump the version. Then for projects that does not support ARM in the latest version, and is still actively maintained, such as native, we will first report and provide patches to the community to provide fix and releases. And some of the projects does not actively maintained anymore, such as NeverDB.GNI. We will provide the packages that have ARM support and discuss the community to use the package if the UV is ARM. By doing that, we will not affect the existing x86 users. After solving the dependency problems, the software will be okay to build, but there are still some functional problems. Some of them are caused by different behaviors on ARM and x86. One interesting problem happened during when debug a process on Spark. Our colleague found out that the calculation, the result is different from x86 and ARM. And after debugging, we found out that Oracle JDK has made some changes that result to the math lib, so that it will run faster on x86 than ARM, but it will cause inaccuracy and the result is different on ARM. So we propose to the community and communities accepted. Since some projects pre-commit tests only run the tests that are related to the patch, and some of our jobs is running daily with the full test. We also discovered some hidden problems. Those problems are not ARM related. They not get discovered only because they have not been running for a long time. Such as we found that in Hadoop, there are some codes and tests that are poorly written. So apparently, our CI does not only benefit people that are interested in ARM. Apart from the CIs, we have also done some primary performance testing on Hadoop by running and comparing TerraSort on ARM and the x86 server, which could also be very interesting to look at. We have set up 3 nodes Hadoop cluster on both x86 and the ARM servers. The hardware are similar. Both have 8V CPUs and 16 GB memories. Some of you may be familiar with TerraSort test suite. It's widely used in terms of Hadoop benchmarking, and Hadoop have provided an example jar file that can be used to running basic jobs. So we use them too. The jar package including 3 MapReduce applications, TerraGen, TerraSort, and TerraValidator. Firstly, we use TerraGen to generate the testing data with 20 GB, 50 GB, and 100 GB. We will testing with more large of data in the future, and we have run TerraSort on those data to see how Hadoop cluster performs in different platforms, and we validated them with the TerraSort validator. We ran each scenario for new terms and summarize the result. From the graph, we can see the results are compatible and in some cases, platform better. And consider that for some amount of money, one can get more resource than x86 resource. We can see that running big data application on ARM data centers could be a very competitive. These are some basic tasks that we have started to work on, and we hope we can get more detailed results in the future. Now I have passed the time to my colleague Job. He will introduce to you some information from some other areas.
Now let's move to a wider angle for this. Let's jump out of the big data project themselves and have a look at what else can affect the performance and user experience. There are a lot of user user non-perception underlayer software and libraries that accept a lot of on the upper layer applications. And we have also done a lot of improving them on ARM platform so that software using them could perform much better. And of course, people from ARM and Linaro have been done a lot of those areas for a very long time. We are just doing our part of the job, standing on the shoulders of giants. So we have done some improvements in some basic and most widely used lib, like in glibc. We have optimized functions like string copy, string length, memory site, and so on in the upstream. And according to the test, we got 5 to 20% improvement depending on different type of data set. And these functions are used almost everywhere. We also have enabled some libs to be enabled to run on ARM platform for the first time, like the ISAL. We have added the erasure code support on ARM, and after this, advanced features like the HDFS erasure coding with ISAL could also be used on ARM platform. There are also some undergoing works like the in the Snappy and VSTD, which also affect big data software. In case you are interested, here is a link to our current work item for this kind of jobs. Now let's have a closer look at what we are currently doing. In this part, instead of talking about just big data related works, we are give you a full map about what our team is currently doing. So first of all, I would like to introduce another important of common use case for data centers, the databases. There are quite a lot of customers that ask to know how will those databases run on ARM. Similar to previous mentioned big data projects, our plan for data projects are also test and improve. For some projects, like MariaDB, we donated our resource to help them verify functionality on ARM platform. And we have also started to discuss with projects like Percona and Green Palm to have a plan to donate our resources. And for some other projects that you use other internal test resource like MySQL and MongoDB, we have started to discuss with them to provide ARM tests or releases. Apart from the CI testing, we are also proposing some features so that the databases works better on ARM platform. At the start, we work on the most popular database, MySQL. There are currently 3 fields that we are currently working on. The first one is the element of ARM cache-line. As some of you may know, some ARM chips now have higher cache-line size than the rival x86 chips, and if the software still use the same cache-line configuration, then our resources are wasted. So propose a way to be able to alien the cache-line when we have a larger size, can use the hardware advantage and be more competitive. Another one is the CRC CPU feature. This one is not playing in MySQL. MariaDB also showing interest in and is willing to cooperate with our team for developing and testing this feature. We are still discussing the detail about it, and hopefully it will be developed soon. The last one we have on hand is the transaction system lock speed. This feature will improve the performance in parallel cases. It is also in early stage, and we will share our results with the community once we have done the development and tests. Now let's turn back to my colleague. He will introduce our current works in big data area.
Just to let you know, you have 3 more minutes. Hi, sorry, I don't know if you heard me. We've got 3 more minutes, so you'll need to start wrapping up soon. This is just a reminder.
Okay, thank you, thanks, Job. So in the big data area, as mentioned before, we have Hadoop CI, and it has been steadily running for a while. And now the Hadoop PMC Burma from our team has started discussion about publish the ARM release package for Hadoop. With the package, user won't have to search for docs on how to build it and build it themselves. Instead, they can just download and run in a snap of fingers. We will provide required resource and long-term support the ARM release for the future versions. Aside from that, we have also proposed some new features to the community. The first one is MADIM. For those who not be familiar with it, MADIM is a non-volatile memory. Another feature is SM4, which is blocker cipher used in China National Standard for Wireless LAN WAPI. Also we also work on other software in big data ecosystem such as Kudu. As usual, our first step is to propose adding ARM-CI support. We have opened an issue in the Kudu community to discuss about support ARM for Kudu get positive opinions. Now we have submitted a big patch to Kudu Garrett. The building process is okay and more tests can pass now. We still have some test cases that have to find the root cause. We also plan to add ARM-CI support for Impala project and Storm project in the future. We have submit issues in each communities and had got positive opinions, and we have do some initial attempts. Okay, let me return the screen to Jing for the updates in virtualization and cloud.
So we have only 1 page.
Yeah.
1 page.
Oh, you've got 1 slide. Okay.
Yeah. Okay.
Right.
So we have also done a lot of things in the virtualization and cloud field, and as normal, we're starting by identify the gaps between ARM and other platforms. Actually, it's not very good. Only from the line of codes, we can see that from the libvirt, x86 CPU driver has about 3,400 lines of codes, and even PowerPC 64 CPU driver has 800 lines of codes. But ARM CPU driver only have 250 lines of code, so that's a very big difference. And speaking of features, there are some basic features are missing, like the capability show and CPU compare. Those are very basic features which are missing. But hopefully we have talked it to the community. They are very welcome about working on those areas. So we are going to working on those areas in the future. What we are going to do is that we will keep on working on our current fields and some other new fields. And you guys are very welcome to cooperate with us to make a better future for the data centers. And here is our Slack channel. And if anyone has any question or any interesting topics, can join this Slack channel and ask us. So that's all.